Hello everyone and welcome to the second edition of Couch Cruisers. This time around we're going to be looking at sailboat keels. We're going to examine what the keel does for a sailboat, why sailboats have keels, and the common types of keels, both fixed and movable. So the sailboat keel is a wing or fin that extends down from the bottom of the boat. The keel can be weighted or unweighted, and it can either be fixed or it can move back up into the boat to allow the boat to go into a shallower location or a shoal draft keel. Keels come in a lot of different configurations and they mostly look nothing like the picture that I drew here. All I'm trying to illustrate is where is the keel located. Now sailboats have keels to reduce the amount of slippage to leeward, and leeward is the opposite side of the boat from where the wind is coming from. Sailboats So, in order to have a decent discussion about sailboat keels, we need to talk about the forces that are acting on the boat so that we can better understand what is the keel doing and why do the different configurations matter. So, here in my diagram, I have the wind coming from about 45 degrees off of the bow. When the wind comes in on the boat, it's going to hit the sail and be redirected aft or towards the back of the boat. When the wind comes in and hits the sail and goes aft, that is going to create a forward push on the boat a little bit because the wind is being redirected to aft, but the wind coming in and hitting that sail is also going to create a force towards the lee side of the boat, and that's going to be the largest acting force on the boat. So up here I have a diagram showing the forces acting on the boat. So as we said, the wind getting pushed by the sail backwards or redirected backwards will have a small forward acting force on the boat. The wind hitting the large surface area of the sail, pushing it to leeward, will have the largest force on the boat. And when you add these two forces together, you can see the direction that the boat would travel. And this is an example of what would happen to a sailboat if it did not have a keel. So here we have the same diagram. We still have the wind coming in from off of the port side, about 45 degrees. We still have the wind hitting the sails and being redirected aft to give us a little bit of force moving us forward. We still have the force on the sail pushing this boat to leeward, but in addition what we've added this time is the keel sticking down under the boat. And because the keel is sticking straight down under the boat, as the boat tries to slide to leeward, the density of the water being much more dense than the air creates a high pressure against the keel, and that prevents the keel or the boat, since it's attached, from sliding to leeward as much. So you can see here that we have a balancing force from the keel being forced through the water against the wind on the sails, forcing the boat to leeward. So you can see up here in our diagram, we added in that counterbalancing force, one from the keel against the water under the boat, and the force against the sails pushing us to leeward. And you can see that that is going to adjust our direction of travel, since the force to leeward and the force to windward on the keel balance each other out almost completely. So we still have a little bit of slippage to leeward, but not as much as we did without our keel, and this lets us point upwind. So the final thing that the keel does for us is it keeps the sailboat upright. The more upright your sailboat is, the faster it's going to travel and the more comfortable it's going to be, since you're not living your life at 45 degrees. What we're showing here was the forces from a weighted keel acting upon the boat. Now, first of all, because your boat, you have buoyancy, right? You want to keep it above the water. The keel being weighted acts against the buoyancy and pulls the boat downward. The heavier the keel, the more downward force you're going to have, and the more upright the boat is going to sail. The force of the wind acting upon the sail pushes it horizontally and tries to tip the boat over. And you can see that labeled here. So as the wind comes in, hits the sail, the boat tips to leeward. The weight of the keel pulls the boat down and tries to counteract that force in order to balance the boat and keep it upright. Now here in the top diagram, I have an example of all of the forces acting on the boat, the weight pulling it down, the buoyancy pulling it up, and the force of the sails, or the force of the wind on the sails, tipping it over to leeward. Because the weight of the keel must be less than, or the the force of the weight of the keel must be less than the buoyancy, otherwise you're going to sink. You always have positive buoyancy, and here down at the bottom you can see after you use the buoyancy force to cancel out the weight, what your heel angle would look like. And the heavier you have of a keel, the more force you have for that downward angle, and the less heel you're going to have. The inverse is also true, of course. The lighter the keel, the less counteracting force you're. Now that we've looked at some of the forces acting on the boat, we can talk about the types of keels and the advantages and disadvantages of each. So a full keel we'll start with. The full keel extends the entire length of the hull. It has the largest amount of wetted area, and it is also the heaviest. Now, because it's the largest and the heaviest, it gives you the least amount of heel because you have that large gravitational force acting on the heavy keel. Because it's the largest, it also has the most wetted surface. The more wetted surface you have, the more drag you have, and the slower the boat goes. Finally, because it's the heaviest, it gives you the most comfortable ride, regardless of your wind or waves. Following that, we have our modified full keel, and you can see that it still extends most of the length of the boat, but it's got this little notch cut out in front. What that notch does is it reduces the amount of wetted area, increasing the performance of the boat. This is also a heavy displacement, or a very heavy keel, so it has a reduced amount of heel, making the boat more comfortable, and because of the size of it, it'll have a low amount of slippage and be a very comfortable ride. Next type we want to talk about is a fin keel with a skeg rudder. Fin keels are designed to be more of a performance boat. They are faster than the two that we have discussed so far. The fin keel actually has better performance to windward than the full or the modified full. And the reason for that is with the reduced wetted surface, they can go faster and point closer to the wind before they stall out. Now, the fin keel has something in common with the full and modified full, and that is that there is an extra structural member of the keel attached to the rudder. And what that does is it helps protect the rudder from groundings as well as from debris. Say if you drove over a rope, that rope would come along the bottom of the keel, hit the skeg, and then go on its way. Next kind of keel we want to talk about is a fin keel with a spade rudder. Now, like the aforementioned fin keel with a skeg rudder, the fin keel with a spade rudder is smaller, has the fastest performance and better windward performance due to the reduced amount of wetted surface. They are the most vulnerable type of keel and rudder, and the reason for that is fin keels are typically bolted onto the hull, whereas your full and modified full, got my pointer backwards here, but that's all right. With your full modified full, the keel is actually integrated into the hull. With your fin keels, the keel is typically bolted onto the boat. That makes it more susceptible to breaking off in a grounding. And most vulnerable of all here with the fin keel and spade rudder is the rudder itself, because the rudder has nothing protecting it as it does in the skeg rudder configuration. Now, in the previous slide where we showed the forces acting upon a sailboat to keep it upright, with the wind against the sails causing it to heel and the weight of the keel causing it to stand upright, you can quickly see as we move to the right, the reduction in size of the keel is going to give you less of that weight down force, so the boat has to heel more. You can also see as we move to the right, the reduction in size reduces the amount of wetted surface. So in the previous diagram, we looked at the boats from the side. Here we're going to be looking at them head-on. And the reason for that is these types of keels are better discussed from the head-on perspective. So looking at the transom of the boat down the underwater waterline, here's an example of a bilge keel. A bilge keel is different than all the other types because instead of one, it has two keels. This is typically used in areas with a large tidal change, such as England. The reason they use this is the boat can dry out on each tide and it can sit securely on its and flat on its two keels. If you're somewhere with a large change in tides, this would be a great design to have. or you're somewhere that it's very shallow, this would be a great design to have. But because of the wetted surface of having two keels, it is one of the slower designs. Next, the bulb keel. The idea here is to allow to put the weight at the very bottom of the keel. The farther that the weight is moved down from the force acting upon the sails, the more effect that weight will have. So by putting it all into this bulb down at the bottom, you can get more force from the same amount of weight. Finally, the wing keel. As a boat slips to leeward, the water comes against the keel and then flows around it. The idea of the wing keel is to try and stop some of that flow so that the boat doesn't slip as much and can gain better performance. So the water comes in, hits the side, can't find its way out very good, and the boat can sail a lot better. That's reduction of the cross flow. Up until now, we looked at fixed keels. Keels can also be movable and either weighted or unweighted when they are movable. Centerboard and dagger are two types of movable keels, with the big difference being how they move. Centerboards move straight up and down, whereas daggers fold out like a folding pocket knife. Either of them can be weighted, and the advantage to both designs is that they can be lifted up and the boat can be moved into very shallow water. The disadvantage to both of them is then you have a moving part on the underside of the boat that may not be as maintenance-free as one would desire. Lee boards are only seen on small harbor boats because they are unweighted, and all a lee board does is prevent the boat from sliding to leeward, but it is unweighted and does not give the boat the righting force that a weighted keel would, and you will not be considering a lee board for a cruising sailboat. So everything in sailboat design is a trade-off. The keel is no exception. What I'm trying to show here is the different attributes of a sailboat keel and how they affect the overall desirability. So in our triangle here, we have maneuverability of that type of keel, the performance or speed of that keel, and how comfortable it is. And then you can take the different types of keels at the bottom and assess the characteristics to pick one that works well for you. So if comfort is most important to you, you might look up here and say, okay, comfort, I'm going to want an orange or a blue one. So I want a full or a modified keel. And then I care about speed. I want to get there eventually, but it's not a big deal for me. So let's look at the speed. We'll probably go with the orange one here because it's a little bit better than the full or than blue. And maneuverability, we're not going to be operating in tight places. We're looking for ocean passage, so I don't care about maneuverability at all. With those characteristics, it looks like orange would be my personal choice. But if you're going to be operating somewhere where maneuverability is important for you, you might want to look at the fin keel, because most maneuverable, if you need to get in and out of slips, in and out of tight harbors, maneuverability and performance for a quick boat or for a racing boat may be most important for you. Hope you enjoyed the show. Go ahead and leave me a comment if you liked it. If you didn't, either way, I'd love to hear from you.